Good morning, everyone. Myself Ram Reddy. I am from EC department, and the subject is antenna and the wave propagation. And the topic is about a beam forming approach for multiport antennas. Introduction to multiport antennas. Multiport antennas utilize multiple radiating elements to enhance performance. They enable advanced beam forming and the spatial multiplexing capabilities. Understanding the design and the operation is essential for modern wireless system of the beams. Types of beams. What is beam forming? Beam forming is a signal processing techniques to direct wireless signals towards specific directions. It improves signal quality and increases system capacity. It is widely used in the 5G, Wi-Fi and the other wireless communication standards. Types of beams. In the picture we can see the types of beams, and the types of beams is the cantilever and the simple supported and the overhanging continuous fixed ended cantilever simple supported. And the significance of the multiport antennas in a beam forming. Multiport antennas provide multiple independent signals flexing beam control. They enable the precise flexible beam of the control. They enable precise spatial filtering and the interface mitigation. The architecture supports adaptive and the dynamic beam forming strategies. Types of beams and the types of multiport antennas. Common type shapes is includes phased array, parasitic and the reconfigurable antennas. Each type of offers different advantages in the complexity and the performance. Selection depends on the applications requirements and the design constraints. Beam forming architecture. Digital beam forming involves signal processing in the digital domain, analog adjust phase and the amplitude. RF domain hybrid beamforming combines digital and the analog techniques for efficiency. Principle of beamforming in the multiport antenna. Beamforming relies on adjusting the amplitude and the phase of the signals at each port. Proper weighting steers to the mean towards the desiring directions. Nulls can be created and the suppressed interface for specific directions. And the a beamforming approach for the multiport antennas is a technique that combines signal proper antenna design to control radiation pattern of antennas. That multiple antennas that allows the directional transmission, reception, interface mitigation and the multiplexing, all critical in the modern wireless systems like 5G, MIMO and the radar. What is multiport antenna? A multiport antenna is a single physical of the principles of beamforming and the multiport antenna. Beamforming relies adjusting the amplitude and the phase shift signals of the each port. Proper weighting steers the main lobe towards desired directions. Nulls can be created to the suppress interface from the specific direction. Mathematical foundations. The array factor describes the combined radiation pattern of an antenna array. Complex weights are applied to the control the beam shape. Optimization algorithms are used to find the best weights for specific scenarios. Signal processing technique. Adaptive algorithms like LMS and the RLS update beamformer weights in the real time. These algorithms respond to changing the signal processing, enhances beamforming robustness and the accuracy. And these are desired considerations for multiport antennas. Limit spacing influences bandwidth and the grading loops, mutual coupling effects, element performance and must be managed. The number of parts determine the beamforming resolution and the complexity. Challenges in the multiport beamforming. Calibration is needed for account element variations and the mutual coupling. Hardware complexity increases the number of ports. Real-time processing demands can be computationally intensive. Calibration techniques. Calibration involves measuring and the compensating for hardware imperfections. Over-the-air calibration methods are often used for practical systems. Proper calibration ensures accurate beamforming performance. Applications of multiport beamforming. 5G based stations utilize multiport antennas for enhanced coverage. Satellite communication benefit for precise beam control. MIMO systems leverage multiport architecture for higher data rates. Performance metrics gain and the directivity quantity of the antenna's ability to focus energy, side lobe levels, impact interface, and the signal quality coverage of the main lobe. What is beamforming? Beamforming is the process of adjusting the phase and the amplitude of the signals. Each antenna, the beam is desired direction on the focus energy toward away from the specific regions. The multiport antennas, this is done with the structure rather than the across of the array of the physical antennas. Core concepts: weight vector design. Given a multiport antenna with ends ports, you define the weight vector W equal to W1 W2 and the total radiation pattern synthesis. The total far field pattern E equal to theta becomes by optimizing you can maximize gain of the target direction, suppresses side lobes, achieve nulls in the direction of the interface. Case study: 5G Massive MIMO employs large multiport arrays for spatial multiplexing. Beamforming improves the spectral efficiency and the user experience. Practical implementations involves complex algorithms and the hardware design. Future trends in the multiport beamforming: integration of the machine learning for adaptive and the predictive beamforming, development for recognizable and the smart antenna systems, enhanced algorithms for real-time multi-beam management. Summary of the key points: multiport antennas applications. Applications, continuous innovations are expanding their capabilities, and the wireless communication challenges and the opportunities. Overcoming hardware complexity and the cost remains a major challenge. Opportunities exist in IoT, 5G, and the integrated communication systems. Research is ongoing to improve efficiency, scalability, and adaptability. And the summary and the beam of practical implementation: input data, full wave simulations are measure embedded alignment patterns for each port. Mutual coupling data is parameters. Target direction or pattern constant. Tools used: MATLAB, Python, NumPy, SciPy, HFSS, CST, or FICO. For full wave simulations, VNA vector network analyzer plus Anxio number of measurements. Performing metrics: beamforming gain and the max power is desired direction. Side lobe levels, SLL, measure how well dense undesired directions are suppressed. Radiation efficiency, bandwidth of beamforming performance. Pattern reconfigurability for switching beam of adaptive systems. Applications: 5G 6G antennas in the smartphone, space limited for factors. Vehicle to everything, V2 to V2X antennas, congruent radius, radar, SSR, MIMO, radar, IoT devices with adaptive link. Possible research contribution, sample paper outline. These are the challenges and the in the we can abstract of the beamforming approach of the multiport antennas in the wireless system. Introduction, background, proposed beamforming approach, simulations, and the results, radiation patterns, plots, and the summary of the key points. Multiport antennas are essential for advancement beamforming applications, and the challenges and the opportunities. Overcoming this hardware opportunities. Overcoming the hardware complexity and the cost remains a major challenge. Opportunities exist in IoT, 5G, and the integrated communication systems. Research is ongoing, improve scalability and adaptability. Conclusion: beamforming for multi-enhances wireless system performing significantly. It offers flexibility. References and the further reading: key textbooks, research papers, Standards document provide deeper insights. Industry reports highlight recent advancements and the trends. Continuous learning is essential to stay updated in the evolving field. Question and answer discussion. Thank you for your attention. For multiport antennas, please feel free to ask question to any share comments. Let explore further topics or clarify any points interest.